Okay, YouTube, and in this video and in the remaining videos that we explore parabolas here, what we're going to be seeking to do is, just given the equation perhaps, could we find the vertex focus and the directrix and then sketch the graph? And so we're going to confront an issue that we're going to run into a lot in this particular video and then going forward, and that is to say that this will not be given to us typically in standard form. What we have here is our general form equation here. Basically, remember that we have ax squared plus cy squared plus dx plus ey to the first plus f equals 0. It's just that in this particular case, it looks like we have no ax squared term here. We have a cy to the second and an ey to the first term. We have a dx term. We have no constant. Basically, we can see that this is something in general form, but what we want to do is write it in the standard form of the equation of a parabola. And so let's go ahead and start with this, with our vertically oriented parabola. And this is how we're typically used to seeing parabolas, is with an x squared quantity. We have x minus h squared is equal to 4 times p times the quantity y minus k to the first. And with respect to our horizontally oriented parabolas, horizontally oriented, we have now y minus k squared, being the squared thing, a squared y, and that's equal to 4p times x minus h. So we can see that h always associated with x, k always with y, and our p, that's going to be our directed distance to the focus. So now, because this equation is not already in one of these two forms right here, what we're going to need to do is we're going to need to place it in that form. And the way we're going to do this is we're going to complete the square. And so let's go ahead and start with this. I'm actually going to just rearrange this a little bit here. I'm going to write y squared minus 4y minus 4x on the left side of our equation here. And what I basically want to do is talk about this. We say our goal is to rewrite as a squared binomial one of these sides. Well, that doesn't look like the word binomial. There we go, binomial. And so when we talk about completing the square, remember that when we had been exploring quadratic, something like this here, we say x squared plus 4x plus 3, something like this here. What we'd rather have it in is what we call vertex form, this a times x minus h squared plus k. Okay, this vertex form, but that involved getting a squared binomial here. And so in terms of getting a squared binomial, to rewrite a trinomial as a squared binomial, often what we do is a process called completing the square. And so completing the square, the way that looks is this. Let's say perhaps we do indeed have something like x squared plus 4x plus 3, and we wanted to write this in vertex form. What we would do is just a series of steps here where we would, let's say, boot the constant. So boot the constant term. And so the first thing we ended up doing was, let's throw this 3 to the other side, and we have x squared plus 4x. Now the next thing we want to do here is we want to add a constant to both sides. But that particular constant we want to add here is this. Add half of b squared. Or add the square of b halves to both sides. Now when I mention b, okay, essentially what I'm mentioning is that we have something that looks like this, x squared plus bx plus c. And so to add b halves to both sides, basically what we're saying is that our b value is equal to 4 here. If we were to say half of 4 squared, if we were to cut that in half, so cut this in half and square both sides here, we would basically be saying, well, half of 4 is 2 and 2 squared is 4. Let's add 4 to this side, but we also have to add it to this side, such that the left side now would say y plus 1 when we combine these like terms here. And then the right side we have x squared plus 4x plus 4. Now the fabulous thing about this quantity right here is that it is a perfect square trinomial because we added half the middle term squared onto it. And so that is to say, if we were to factor it, we would get two factors, x plus 2 and x plus 2, but more succinctly we would say that we get x plus 2 squared, and here's our squared binomial. This is what we want, a squared binomial. So with respect to completing the square, we're going to do this quite often, and as a matter of fact, let's go ahead and take a look at that slide that I had open here. This right here, what I want to do is walk you through how we might treat something like this if it's not already in standard form. So the first thing we're going to do is get the squared variable type isolated on one side. That is to say that our squared variable type here is y. And so what I'm going to do is I'm going to take anything that doesn't have a y and I'm going to displace it to the other side. So what this step would look like is y squared minus 4y, and this would be equal to a positive 4x. So now, this was our first step here. What we'll do is complete the square. So complete the square. Rewrite the squared side, squared type side, as the square of a binomial. Square of a binomial. So that is to say that on this left side, we're seeing that we have this y squared minus 4y plus nothing is equal to 4x plus that very same nothing. The question is, what would I want to add here in order to make this a perfect square trinomial? And the neat thing is that we would just say that it's half of negative 4 squared. So half of our negative 4 is negative 2, and negative 2 squared is a positive 4. We'll go ahead and add this 4 to both sides of this expression. And then the neat thing that happens is that this left side automatically has to factor down into the square of a binomial here. And so this, rewrite it as a square of a binomial thing, we'd say, well, what could I multiply that would multiply out to be a positive 4 but add up to be a negative 4 here? And we would say a negative 2 and a negative 2. What I want to say here is this: when you factor a perfect square trinomial, this is always half of the b term. Try that again, term. So this value right here is half of negative 4 here. But once we get this squared, what I want you to see is that this is pretty neat. We are almost in what we refer to as the standard form of this parabola. As a matter of fact, we have this horizontally oriented parabola where we've got our y minus k squared item on the left side, and that's what we want. It's just that the right side, you'll notice that specifically if we're in standard form, the coefficient of x and y inside these parentheses is always 1. And so what we're going to do is factor out the leading coefficient on the right side here, coefficient. And what we'll get is this final expression says y minus 2 squared equals 4. Whatever this is, we'll factor it out. So I'm going to factor out a 4, even if it doesn't leave a nice pretty 1 left behind over here. But what we get is this. And so the neat thing about this is, let's go ahead and put a box around this. We're going to say that this is our standard form. And the standard form of a parabola is pretty neat because what it tells us is it tells us where the vertex is to begin with. It's at h and k. And so because our h value looks like it is a negative 1 here, and our k value looks like it's a positive 2, we could say that we know that going left 1 and up 2 already provides us with the coordinates of the vertex. I'm going to write vertex here. Because the y term is the squared term here, this would imply that we have a horizontally oriented parabola. So that would mean our axis of symmetry runs through it left and right through the vertex here. Now, with respect to p, the thing here is that we have h here and we have k here, but what we have here is always just 4p. So what this is going to mean is we're going to need to always solve for the value of p, and in this case p is positive 1. So now, because I know that p is positive 1, that would mean that I'm going to go along the axis in the directed distance from the vertex to get to our focus. So that is to say, since p is positive 1, we'll go to the right one, okay, from our vertex here that is at negative 1, 2. We can label that negative 1, 2. So this must be the point 0, 2 right here. So we're going to write a little note that our focus then is 1 to the right of our vertex, so it must lie at 0, 2. And then our directrix is the last thing we're going to find. Remember that the directrix is always the p units the other way from your vertex here. So if we were to go backwards to the left p units from the vertex, we would land right here at this vertical line. It runs perpendicular to our axis of symmetry. And we'd say this has the equation x equals the value negative 2. Because we went 1 to the left of this original x value that was at negative 1, we're now at x equals negative 2. So our directrix has the equation x equals negative 2. So this video illustrates a particular example where we had to complete the square, and this is going to be something that we're really going to have to get used to doing going forward, because most of the time we are going to be given things in general form and then asked to rewrite it in this standard form where we'll always have a squared binomial. Cheers.